That's where you download these satellites from. So it's the website. Go to your browser. The website is earthexplorer.usgs.gov. So just add Earth Explorer. I hope the network is strong enough to take over. I have to skip this to show you how to download digital elevation model online. That's the purpose of this. So you must have an account which you have to sign in. Just put Earth Explorer. Yes, that one. So you click on it. Yes, click on it. So I already have an account. You don't have. No, you don't have an account yet. That is your Chrome account. So click on login. Now, you don't have account, go down. Click on create account. Okay, so once you have an account, you can do everything. The only thing you can't do is download. So let's learn the steps together. So now we have here, under here, we have search criteria. Under search criteria, once you are logged in, you will see other options. You will see options like search, role, and all of that. But yours now, I think, let me know. Okay, you can only see path and row and feature. Right? But then you can pick a polygon. You can just locate where your continent is. This is Africa, eh? Okay. Know that this is Nigeria. So I know this is Nigeria, this is Kaduna, this is Kaduna. So Zaria should be somewhere. This is Kaduna town, like main town of Kaduna. Yeah. This is main town of Kaduna. So if you follow this up here, we should be able to see Zaria. Since you don't have, this is around Niger country. So we're just going to pick anywhere. So once you find that place, you just do like this. Make a selection. Let's say this is where you want to download, right? So now I'm going to pick mine. But you see since I'm logged in, I have option of search address, so I can just search for what's the name of the local government? Let me search for Mina. You cannot search, not that one. You cannot search. The search starts from up. So you see, once I click here, you see that it will take me to Mina without me doing anything. But since you are not logged in, you won't be able to access this feature on your own. You understand? So now, when you come down here, what they are telling you is that you want to select date. But this is when you want to download Landsat and other data that are temporal. But for DEM is not, you don't have temporal data. So what you do is that you just click on dataset. Then after on dataset, you go to digital elevation. So on digital elevation, you come down. These are all digital elevations, but this is the one we use more, SRTM. So you come, then you click on this SRTM 1 arc second global. So once you click on it and you click on result, it's going to search and display result of digital elevation of this area. So you see, we have one. So this one now is the digital elevation of this area. So if I click on download now, it will just download. But you must be logged in to be able to download it. So you search, later you just go through, create the account like we just did. You saw everything we did now. Just try and create the account again. Once you've created the account, you'll be able to download this. Okay, after downloading, go to your ArcGIS. I didn't download because I have the exact. So you go to your ArcGIS. So you go to the folder to which that file is. So see the file here. This is the file. So if you check, it's going to cover. So this is the file, right? So you can see that even this one was swallowed up by it. So now you bring in the location of this, so which I will do now. Oh, this is okay. This one is something else. Common. I don't know which one is. Was check. Okay, study. Yes. So this is the shapefile. So now I'm removing down because we'll redo another one. So with this, you can just extract this place, which is clip. We did clip yesterday, but the clip we did yesterday were for vector, right? So you come here and you search for clip, but I have issue with my keyboard. I'm not going to start for clip. Rather, I'm going to start for extract by max. So the clip will come out also. So 2 items will come out. If you extract by max, it will still give you this. If you clip, it will still give you this. So it's clip we are looking for. So we just click on clip. And once you click on clip, you bring in this one. So you click on it. Then your output, which is the same thing as the one we did yesterday, is the study. Now, but here you're going to check this so that it will maintain the clipping on this study area. You understand? If you didn't clip this, it's just going to ignore it. You understand? So then I will just select where I want it to be. So I'll just put it here. I'll just say Mina. Always include .tif so that you don't .tif and click on save, click on OK. So let's uncheck this and uncheck this and wait for it to finish. So you see that it has given us, I don't know, it has given us the exact thing we removed, right? So this is how you download. So you download SRTM, that's the elevation model, and then you also clip it. All right. So once you clip it now, which is bringing us to what we're supposed to do today. First, just go back to your ArcGIS now. Just leave it and go back to your ArcGIS. So go back to your ArcGIS to where we are now, right? Good. So first thing, one of the first analysis we want to do here is to reclassify this elevation. You can see it's only on low and high. We can actually reclassify it to have other things. Now, if you're doing factor analysis, let's say you're doing suitability analysis, which was what I used in carrying out this suitability analysis, you need some factors like elevation, you need factors like slope, you need factors like all of that. So we'll be creating most of those factors here. So we're using this so that you understand what you can use SRTM, this digital elevation model, to do. So to reclassify, you right click on the Mina, or your own is Buso, right click on it. Then you go to properties. You go to symbology. Then you go to classify. Classify. Are you on classify? So on classified now you're gonna see, you will see 5 classes by default. So if you want it to be more than 5 class, you can click and increase it. But better still, you can, the best class is 5. Alright? So now next is your left click. Left click on that label. Under the label, just left click. Not right, left. Left click, you're going to see format labels. So change that numbering to 3 so that you only have. See the next one now, format label. So you remove that 10 and make it 3. You can click on it and so you click on OK. So you see that this thing has changed to just 2, 3 decimal number. Didn't you see this? It was.
I didn't see it before.
All we need to do is to put 10 back. So this is what we're talking about. It has plenty numbers. So you want to just sort it to 3 decimal places.
Okay.
So you now see it. It makes it better and all that. So now next you go to coloring. You go to that color ramp. And then choose a color that suits your style. Me, I'm choosing this color. Choose any color of your choice. So I have chosen a color. Just click on apply and see. So no, if you drag it one side and see what you've done. Now, in some cases, to produce an aesthetic map, you just click on this. Use hill shade effect. Yes, you have to go back. So click on hill shade effect. But it's just when you want to make something aesthetically pleasing. Alright? So see what it does to me. Click on apply and see what it does for me. So you see it's making him look like a 3D kind of. So it's just to have something aesthetically pleasing. Do you understand? That's why I said it's just for aesthetics, nothing better. So if you change this thing now you see it's because it's number 1 that if you change this to 5 now, it should increase the hardness of the. If you make this 10,
before it was like smooth.
Yeah, so you see now it's making it look more. Do you understand? So the Z is just to exaggerate it more, so that you can be from the this thing. You should still see it look like.
So that is a 3D model.
Yeah, it's not really 3D, but it's just. So that is just the purpose of the Z in that place. Yeah. So do you understand? So in case, let me also increase my hair. So the Z is just purposely to have an increment in the changes or whatever of this elevation. So you see mine now, she's becoming hard. So it just make the color more, like it just make it more colorful and all of that. So it's aesthetically pleasing. If you see this, at least it gives some vibes in your system and all that. All right. So and then the categorization is what gives rise to different colors. If it's just 2 and above, like let's say we just decided to go to properties. Let's say we just decided to use the stretch which was giving us up and down. Now, if we change the color, it will just apply on the two. So see, it's just going to be like this, which will still make it look more like a digital elevation model that we just color it. So if we also we can also put the heel shake effect here too. And then you see, do you see? See how this heel shake effect makes it looks. Put the heel shake, use heel shake effect. This one, then make it 10, let's see. So whenever you put the heel shake effect, it now makes it look like it's look okay and all that. So the heel shake is not every map that is accepted. Sometimes people you are making it for may not like it. But once you make it, you can decide to make an sense. If they don't like it, you change it. All right? It's just a matter of pressing a button. Yes. So, any questions so far? So this is how to classify elevation. So,
The question I have to ask you
yeah.
about that my assignment, as I showed you before, is from the direct of the
It's on that website that
I will change
you no. From there you will download the Landsat. From that site that we just went to, once you register, you should be able to download Landsat. Now, if I want a Landsat imagery here now, I will go back to search criteria. So from search criteria, let's say I'm searching for Zaria. So the Landsat image of Zaria. So once Zaria pops up here, you must be logged in, like I said. That is, you must have created an account and be logged in, like the way you see my LI Geospatial. So once you click on search, Zaria should appear, and you click on Zaria now. You know that this one now, you'll be able to get a Landsat coverage of Zaria. So here you're choosing the date if you want, but if you don't want, let's say you're only looking for this year, 2025, you go to data set. Then you first come down to Landsat. See Landsat down here. So on Landsat, you select Landsat Collection 2 Level 2. Now Landsat Collection 2 Level 2 is already a pre-processed this thing from atmospheric distortions. But Landsat 2 Collection 1, you have to do all the radiometric calibration and all of that. So, but the 2 Collection 2 has already been done that. So he's asking for ETM Plus, which is Landsat 7. But the problem now is Landsat 7 beginning from 2003 has a scan line that the scan line corrector on the satellite turns itself off. So the cost of fixing that on space is, so they have to launch another Landsat. Now they've launched 8 and 9 already. So you have to either go beyond, like go to get a Landsat that is below 2003. So if we want to do that, we'll come back here to search criteria and select 2000 and 2000. Okay, let's select 2000. So we just make this 2000. So we'll click on this, and then we select Landsat 7. Then we'll click on search result. So all the results are going to give us between 2000, January to December of 2000. So since we're only looking for just one Landsat scene, we'll check the one without cloud cover. You click on this to check if there is cloud cover. So this has only one cloud cover, which means you can download. So if I click on download button now, I should be able to download the Landsat. So let me download it so that I copy it for you without you going to the line. So do you understand? So it's on the site you're going to download your Landsat. So let's go back to okay. So if I click on this, it should start processing and download for me this Landsat 7, which is around 700 and whatever. So that's the first thing to do on elevation. Now the next thing I want to do is to create an inclinar distance. Inclinar distance is still a factor. This is like factor 1. All right. So I'm going to copy this and paste it. I'm going to paste it so that we'll leave this one out. So I will leave one out. We already have an elevation. Now we want to use this to create incliner distance. So you come to search, go to search, you copy, you just copy, then right click on this and paste layer. So you go to search and then search for I made any mistake. Maybe it's I ne. Come. I think I did to make it. Let me go and locate it on catalog. Maybe I made a mistake with the spelling. So on toolbox, which tool should this be under? Which tool should this be under? Should be data management. Common. Yes. Search and see. It did not come out still. Let's remove one C and see. Did it work? What is happening? Let's search on. No. It's not gonna work. So let's search online. Let's search on website and see. Let's search on website. So that's what I spelled now. Okay, one C. Okay. Let's try again and see. Oh, I was right. Just the one C added from the beginning. So we have included distance and we have included direction, which are the things we'll be using for this. So included distance now, from the SRTM, you should be able to calculate the distance. So this included I mostly use for distance from road, distance from rivers, and all of that. So you can calculate that directly from the SRTM, or you extract the stream network and calculate it also from inside. All right. So when you want to use, let's say you want to calculate distance from road, distance from river, you use inclinar distance, or you use BOFA. But inclinar distance is actually the best tools you can use for calculating those kind of distance. Okay. My own as well. So now bring in your, yes. So it's either a raster or any of these, it will work. Either you bring a raster or a future class, it will work. No, mine just stopped. No, you just select your your output. So you put it in linear distance. .tif. Nice. Aperture is just off. I have to open it again. So my system is here. Let me bring back my data. It's the data. Maybe I get them for here. Okay, so now the next is we'll be doing the direction. And the direction of flow at some time, that's what we call linear direction. So these are just basic things you can use your digital elevation model to do. That's what we're just going through them. Euclidean, if you just say Euclidean, you should be able to know, not. Okay, in direction now. Okay, good. No, it's not Euclidean back direction. It's Euclidean direction. Back direction is a different thing. That is used for when you're doing optimal routes. Like you want to determine the most optimal routes to follow. That's for mostly it's used for transportation analysis, whereby you have different factors on a multiple criteria level to determine optimal. I think one of my students did a project last year. He did optimal route of Abuja. Like he was able to determine the most optimal route between Garki and Use, so something like that. So that's what you use most of that. But the raster, the Euclidean direction is also another entire. So you bring in your elevation. Yes. No, not this. This is cost part. You're not on the right one though. I said direction.
The direction that
No, it's not direction you pick. This is the direction. You pick this one before you now come and pick this one. See the one we're talking about here. Euclidean direction. So you bring in your. You bring in that. No. The first one. Yes. So you save a location, say Euclidean direction. Your output now. I'm just going to put EUC. So Euclidean direction. .tif. So once you've done that, you just like me that have the shape file. I'm going to go to environment, then go to geoprocessing STM. And this time I'm going to import it because it's not here. So I'm going to go and import it in. So it is study. So I'm going to import it. You see, it's now saying the same data as there. So we now go down to raster analysis. Then you come to marks, but it's not there. So I'm going to go back to the folder and bring study. So when I click OK and click OK, it's going to generate it within this boundary. Do you understand? So when it generates now, it's just going to be within the boundary. So you see, the generation is just within the boundary. It's not outside the boundary. So click OK for yours. But I don't think it's really generated the way I wanted. Let's see yours. Yours generated well. I'm not mistaken. Yours generated well. See. Yes. This is what we're talking about. Yes, this is it. Yours generated well. It's mine that yours generated well. So the direction you can see. Do you understand? So we're just trying to find some basic analysis you can use this thing to do. Okay? But you understand? It's just trying to pick out some basic analysis so that you get your hands acquainted with them. Slope. Do you know how to create slope? Hillshade. What about aspect? What about aspect? Not that one. So we're going to be creating slope, hillshade, and aspect. Okay, so on this you just search for aspect. No, everything we're doing is this one we're using, not the one we created. So you search for aspect. We are searching for aspect. So once you search for aspect, you click on search. So now right click on this aspect. No, the second one. Then go to locate in catalog so that you see all the tools we are looking for. So we have aspect, we have contour, we have hillshade and slope. So those are the ones will be. So now let's start with aspect. So you double click on the aspect there. Your input is your digital elevation model, yes. And then if you want it to be within this log, you go to environment within the context, you remember? So, and then you bring in this again, the study. That is if you don't want it to be, if you want it to be safe in a separate location, you have to define a location. But if you don't want that, then all you need to do is to leave it to go to the default folder. Yes. So you just leave it, and then you click on OK. So that's your aspect. See my aspect. You see that they are the same. See that this is aspect. An aspect, basically, I don't know, but how do I explain this? Well, aspect classify everything into these regions. It's more like the direction of the slope. The direction of the slope is aspect. You understand? So you can say slope direction is aspect. So it's direct to the north, to the south, northeast, northeast, southeast, south, southwest, and all of that. So you can see it ranges between -1 to 360 degrees. If you look at it, flat is -1, north is 0 to 22 degrees, northeast is 22 to 67, like that. So it's just the direction of the slope. That is aspect. Okay? So, and aspect are also factors you can use in determine suitability analysis also. So let's go back to the catalog and let's select contour now this time around, which is the second one. Contour. Now go back to catalog, not here. Click on catalog. So contour. Now inside contour we have 3 kinds of contour. We have contour. The first contour, you can use this slope or any of these things to create contour directly. The contour list is when you are using points. You will list the contour. You have the elevation. You list them. Okay, I want it to be 100, this to this to this, that to that. Okay, let's try the contour by list so that you understand what I'm saying. So we input raster. Yes, contour list. Input raster is our elevation. Now you're listing the contour value. Do you understand? So let's say you want to have 5. Let's say we have. Now look at something. Our maximum here is 493. So I want my contour to be 100 at 200 at 300 at 300 at 400 at 500. So I've listed 5 contours. Now if I click on OK, now it should generate contour based on that. That is contour by listing. So do you see? Look at. So what it does is that it summarizes the contour based on those elevations. So only having contour like this on those higher axes of it. Do you get my point? So that's how to use contour by list. If you click on OK, you see it just created the contour based on the higher level of the. So you see what I'm saying? So it has created a contour. Now let's go back to the catalog and use the main contour, which is the contour first one. Now this you input your raster, which is Tmina. The first one, the first contour, yes. So you bring in your. Now here they are asking for contour interval. You see, they didn't ask for contour interval the last time. Now they're asking us for contour interval. So let's say we put 5 meters for our contour interval, and then we'll click on OK. So it's going to create a contour. I believe it's going to have plenty. So you see, it's so plenty. See, the contour lines are so plenty. Do you see? Zoom and see. So this time now you can. So uncheck it now. That's what you want to do. You're unchecking contour instead of. See, the contour are very plenty. So if you wanna, you have to put 10, 20, 30 until you have contour that represent your interest. So contour interval 2, 3, 2, 10, 2, 5, 10, 15, 20 are good contour intervals. Alright, so you interpret well of your result. So, do you understand now? So, next we'll be producing is the curvature. For curvature, you're not feeling anything. Just click on OK. No, just ignore the Z. So it has produced a curvature for you. So do you now see your curvature? Remove the contour, you should be able to see your curvature very well. So you see the curvature?
Yeah.
Come on, where's the contour? Okay. So you see the curvature? So that is a curvature. They are all factors. If you want to understand all of these things, best you just read up what each of them was, curvature, was aspect. Just have a reading on them. You understand where to really apply them. Do you understand? So I think, is it the last? Let's check what I think the last thing we're doing, slope is the same direction, same thing. So let's do the slope first. So slope, you just bring in your what? Yes. And then for slope, there are two, a degree and a percent rise. Depending on what some tax you do requires you to use degree, some will require you to use percent rise. But until you understand fully what you're doing, you know which one to use. So let's use degree now, and then we'll click on OK. It's going to produce for us a contour, a slope. So you can see our slope. Hello? I do MSc class of geology. Geology. So, do you see your slope, right? Now, those are all the factors and what you can use your distance to do. We've created contour, we've created slope, we've created aspect, we've created curvature, we've created inclinal distance, all these, and many more which you can use your elevation to do. All right? So, I think lastly for this is the hill shade. Now the hill shade is different from that one. That one is the effect. That one is the effect you use. This is the hill shade itself. So pick your... Now the altitude, it defines it as 45. The azimuth also defines it as 315. You can use the least value of this, either 90 or 80 or anything, but you can leave it at 1 also. You know what Z factor does at that time. So let's say we make this 45 as well to see. Or we make it 10, just like we make 10 the other way. Yeah, so, and then you click on OK. So you watch it produce itself. So, did you see the effect of, you see the heel shake? It's a heel shade. So you now see with the 45 we put, you can see what it produced. You say? The elevation, good. That's because we make application of the Z factor. So do you understand now? Okay. So any question?